We have another example on the board. Again, we're supposed to determine the output waveform when the switch is open and switch is closed. Look at the first input of my exclusive OR gate. It's connected directly to VCC. It means that this input is receiving always logic 1. Because switch is open, okay, I'm going to simply have over here always 0 because this pull down resistor is connected to ground and this connection gives me logic 1 at this input. Next, you're supposed to look at the truth table. If exclusive OR has logic 0 at one of the inputs and logic 1 at the other input, the output is going to be high. Okay, so I'm going to draw logic 1. Okay, so this is the first part of my problem. Okay, I can say that this is the half of my answer. Next, I'm supposed to close the switch, okay, and apply the input signal to the gate. Now, we're supposed to draw the dash line at every single transition of my input waveform. Okay, we're supposed to draw the dash line at every single point when you notice the change. And next, we're supposed to perform the analysis. We have 0, exclusive OR 1 gives me 1. 0, exclusive OR 1 gives me 1. 1, exclusive OR 1 gives me 0. 0, exclusive OR 1 gives me 1. 1, exclusive OR 1 gives me 0. 0, exclusive OR 1 gives me 1. 1, exclusive OR 1 gives me 0. And I have 0, exclusive OR 1 gives me 1. So this is my output waveform when switch is closed. Please notice that this waveform is complement of the input waveform. So I can say that these two waveforms are the solutions to my problem.